So besides just proving that triangles are congruent, you might also be asked to use parallelograms in proofs or to prove parts of parallelograms to be congruent or whatnot. So the following are some examples of the way parallelograms are used in proofs. So first, here's your information where you're given and you have to prove. So given that ABCD is a parallelogram, we're going to prove that angle BAD is congruent to DCB, and it wants us to prove that angle ABC is congruent to angle CDA. So the very first thing we have to do, if it's not provided for you already, is kind of draw a picture. So we draw a picture of a parallelogram, which is like a rectangle that's leaning. We're going to label it A, B, C, D. You always go around labeling the letters clockwise around the parallelogram. So it's not A, B, C, D. You have to go around it. And then you got to check to see what it's asking you to prove. It's asking for you to show that BAD, which is the pink angle up here, is congruent to DCB, which is the pink angle down there. So opposite angles, that they are congruent. ABC is this green little dot right there, and CDA is this green little dot right there. So it's wanting you to show that both sets of opposite angles are congruent. So the very first thing we're going to do is write our statements and reasons. So the first, that ABCD is a parallelogram, is given information. Okay, that's our only piece of given information. So we've got to think about what are some things that we know about parallelograms. So we know that AB is congruent to DC. That's a property of a parallelogram. We also know that DA is congruent to BC. Now the little S's that you see right here, I'm marking that just for my own knowledge as it's a side, right? So right here, in parallelograms, opposite sides are congruent. We also know that BD is congruent to BD. That's the reflexive property of equality. So BD in this triangle down here is the exact same or congruent to BD for the triangle up here. So what we know is that triangle ABD, which is this top half up here with the pink angle, is congruent to CDB, which is down here on this side. So they're congruent by side, 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 because we've already shown that these two sides are congruent, these two sides are congruent, and that third side is congruent. What we know now is that the two angles it's asking us to prove are congruent, because corresponding parts of congruent triangles are congruent. So now that we've proven both of these triangles are congruent, I can go a step further and make a statement about these two angles. So we're going to do the same thing, go in the other direction. AC is congruent to AC. Again, we've already talked about AB and DC. We've talked about AD and BC. So we can say that triangle ABC, which is the one over here with this green dot in it, is congruent to CDA, which is down here. So again, by side, 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 because we've said something about the opposite sides already, and now we've identified this diagonal as being congruent as well. So the two angles with the blue dots, ABC and CDA, are congruent to each other by corresponding parts of congruent triangles are congruent. So it asks us to prove this angle right here, which we have, and this angle right here, which we also have. So we just proved that opposite angles of a parallelogram are always congruent. So the next one more example, and then we're done. Given GHJN and JKLM are parallelograms, it says that H and M are collinear. That means H and M, even though they are not on the same parallelogram, H is here, M is over here, they are on the same line. And it also says that N and K are collinear. N is in this parallelogram, K is in this one, but they're on the same line. So I was able to draw the parallelograms like this. They're touching at that corner. It wants us to prove that angle G, which belongs to this parallelogram over here, is congruent to angle L, which belongs to the other parallelogram. So the first thing we do is we address what is given to us. And what's given is that GHJN and JKLM are parallelograms. That's our only piece of given information. We also know that angle G and angle J, right here, and that really should be NJH to talk about this angle right there, And angle L and angle J are congruent to each other because we just proved up here opposite angles are congruent. Opposite angles of parallelograms are congruent. Then we can say angle HJN is congruent to KJM because vertical angles are congruent. So now that I've shown that G is congruent to J and that L is congruent to J, and each of the two J's are congruent to each other, G must be congruent to L by the transitive property of equality. So the transitive property is if A equals B and B equals C, A must equal C. So that's how the transitive property works. So we may be asked to use some parallelograms and prove some pretty well established theorems that opposite angles of parallelograms are congruent, for example, in our proofs as we move forward.